Hello, grade 11s. We are back with mathematics here with Sihle. We are doing number patterns today. This is the easiest section in grade 11 mathematics. Okay, guys, but before we get on to the whole chapter, I want us to look at some terminology here. What do the following words or terms mean? A sequence, general term, arithmetic sequence, geometric sequence, and a quadratic sequence. I'm going to give you 3 minutes to just discuss amongst yourselves these words, and then we get on to proper business. Okay, let's take 3 minutes. Well done, guys. Let's just look at the terminology now, and I'm just going to give you some examples falling under your sequences, general term, and so forth. Okay, so now if we look at, for instance, if I give you 2, 5, 8, 11, all right? So this has got a difference of 3, and it follows each other in a certain pattern. So you've got 2, 5, 8, and 11. Right, this is a sequence, okay? Now, when you grow older, when you get to grade 12, they'll be talking about a series, okay? So it still looks like a sequence, but in between, you've got a plus, but we'll get to that when you get older. That's next year. All right, and your general term, sorry. Now, if I want to extend this to maybe 100 terms or 200 terms, 400. I'm not going to write all of these terms. I need to have something that generates all these terms. So in other words, I need to have some sort of a formula that works for all these terms in this sequence. Okay, for instance, this one, in order for us to work the general term, we normally represent it with the Tn. Okay, the difference is 3, so you'll do it by inspection, so that's 3 n, but I want to get to the 2, so if I put a 1 here, so T1 will be 3. Need to get to the 2, I have to subtract a 1. So now if I want to work out for term number 2, so I'm going to have T2 is 3 bracket 2 minus 1, which is a 6 minus 1, and then we get a 5, right? T3 will be 3 by 3, that's a 9 minus 1, which gives us 8. So it's going to work for all these terms. So it's now easy for me to work out term number 100, for instance. Okay, so if you were asked to get term 100, you will say this is 3 bracket 100 minus 1, and then your 300 minus 1, then you are able to get your term number 100. Okay, right? Now, guys, and then from there, we look at your arithmetic sequence, okay? Now, when we're working with sequences, we've got different types, but you guys at grade 11, you need to look at those patterns, and then you have to be able to see what kind of a sequence is that. We will be talking about arithmetic sequence, geometric sequence, all right? Like that one, the one that we just looked at is 2, 5, 8, 11, okay? And what do we notice here is that there's a difference of 3. So if I take term number 2 minus term number 1, I get a 3. Term 4 minus term 3, I get a 3. So we call that a constant first difference. So for your arithmetic sequence, it will have a constant difference. So constant first difference, right? So how do you get that? So D will be term number 2 minus term number 1, or term 3 minus term 2, or term 50 minus term 49. Okay. Now, you will be able to work out the general term for an arithmetic sequence. We will get to that, which is Tn equals to a plus n minus 1 into d. So at a later stage in this series, we'll be able to talk about your general term. And then now your geometric sequence, right? What's different from there is if I give you, for instance, a 1, 2, 4, 8, 16, all right. If you look at the differences here, you've got a 2 minus 1, which is a 1. 4 minus 2, it's a 2. So you see the 1 is not the same as the 2. 8 minus 4, it's a 4. So you're getting those differences, they're not the same throughout. So it means straight away that is not an arithmetic sequence. But if you now say this, if I'm taking a 2, I divide it by 1, I get a 2. And then again, if I take a 4, divide by 2, I get a 2. An 8 divided by 4, I still get a 2. A 16 divided by 4, I get a 2. So we call this a common ratio, right? So your R is term 2 divided by term 1, or term 3 divided by term 2, or term 50 divided by term 49. And then you are still going to learn how to generalize this. This is ARN minus 1, but we're not going to dwell on that. We just need to to know the differences for now. Okay. All right. And then the quadratic sequence. You have done this before. We're just doing a recap, but the most important one that you get introduced to is your quadratic sequence. And earlier in the year, you've talked about quadratic equations, right? So now with the quadratic equations, and you know the standard form, it's Tn equals to an squared plus bn plus c. All right. Now, if we look, as the name suggests, this is a quadratic sequence. How do you get the general term for a quadratic sequence? Tn equals to an squared plus bn plus c. You will be introduced to working in different ways of how to find a general term for your quadratic pattern. All right. Now, for some work that you guys need to do as well, you can be given a sequence 5 minus 1 minus 7, and you are asked to extend the following sequence by at least 3 terms. The next one, 8 minus 4, and then 2. I'm giving you 2 minutes, guys, to work on this. You just extending the sequence by at least 3 terms. And then the next question would be, now tell us what kind of a pattern that you have observed. 2 minutes. Well done, guys. Let's just see how well you are doing, okay? Now, let's look at those questions that you guys had to look at. There's 5 minus 1 minus 7. I need to extend this sequence by at least 3 terms. If I look at this sequence, the difference is term 2 minus term number 1, and term 2 is minus 1 minus 5, we get minus 6. So this is negative 6. Now let's check if we're getting the same thing on the next one. Term 3 minus term 1. Now, minus 7 minus, guys, the mistake that we always make of not putting a bracket there. So that's minus 7 plus 1, which gives us negative 6. So that's negative 6. So in other words, for each and every term that we are getting, the next one after the one that we're working with, we keep on adding a negative 6. So now this one will have a minus 6. So it means here we had a negative, it's negative 13 All right, and then if we add minus 6 as well, we get negative 19. Add minus 6, that's negative 25. And guys, please make sure that you keep on checking if you are still getting the same difference throughout, which is your first difference. Now let's look at the second problem. Now if you look at the second problem, this is minus 4 minus 8, that's negative 12. And then the next one, 2 minus minus 4, that's a 6. Now straight away, so it means that this is not an arithmetic progression. So we try something else, okay? Now, if we say this divide by that, you get minus 4 over 8, which is negative half. And then the 2 divided by minus 4, you get a negative half. Now this, we said earlier, it's a ratio, okay? So now it means that this is a geometric series. So for the next sequence, or for the next number, it's going to be multiplied by that negative half. So 2 times negative half, you get a minus 1. Still times that by negative half. You get negative half times a 1, you get a half. Next one is going to be multiplied by a negative half, you get a negative quarter. So you see that is your geometric sequence with a common ratio of negative half. Okay guys, I'm going to give you a break. Just go grab some water, some bread, and then we come back, we continue with some work. All right, guys, welcome back. You are refreshed. Let's move on. We're looking at our quadratic sequence now, all right? So now, as the word says, quadratic sequence. So we're looking at something that looks like this or that, okay? So that's your x, that's your y, and so forth. So it's in a parabola form, all right? So it's Tn equals to an squared plus bn plus c. That is your standard form for a quadratic sequence, all right? So now we will be asked to work out the terms in a quadratic sequence, all right? So it's Tn equals to an squared plus bn plus c. Now, if I were to work out maybe the first term, remember how do you work out the first term? You say T1 is a bracket 1 squared plus b bracket 1 plus c. Wow, this pen is so nice. It changes color in the middle. Okay, so it's a plus b plus c. All right, that's our first term. I'm just going to write it down here. That's a plus b plus c. That's our term 1. For term 2, we'll have in the general term h squared plus b bracket 2 plus c. Now what do we get? We get 4a plus 2b plus c. All right, guys? And then your term 3 will be a bracket 3. Can you see that in the place of n, I'm substituting by the term number, right? So you get 9a plus 3b plus c. So the next one will be a bracket 4 squared plus b bracket 4. So you get 16a plus 4b plus c. Now, if we look at this pattern, we can work out the first difference here. Now, how do you work out the first difference? Okay? Now, this, that, that. And then it's going to serve as our first difference. Now, you go to your like terms, guys. 4a minus a, you get 3a. And then the 2b minus b, that's a b, all right? A c minus c, you get 0. 9a minus 4a, you get 5a. 3b minus 2b, that's a plus b, all right? C minus C, you get 0. 16A minus 9A, that's 7A. And then 4B minus 3B, you get a B. C minus C, that's 0. So our first difference, you'll have your 3A plus B, 5A plus B, 7A plus B. Now, we go further, we check our second difference. What's 5A minus 3B? That's your 2A. And the B minus B is 0. 7A minus 5A, that's 2A. And your B minus B is 0. Now, if a sequence has got a second difference which is the same throughout. Now, guys, if you look at the next part, you'll be substituting with a 5 there. You'll get a 25. 25A plus 5B plus C. Now, you see that you'll have that 25 minus 16, which is 9A, minus 7A, and then you'll get a 2A. So that 2A is going to be constant throughout. You'll have the same second difference throughout. So in a simplified form, your 2A is your second difference, okay? And then your first difference, right, it's going to be your 3A plus B. Now, when you're setting up your quadratic pattern, you've got the original one, and then the next part, it's your first difference. You write it in such a way that it compares to the one that is given to you. And then there's A plus B plus C, which is your term number 1. All right. Now, we are going to work with this information to extend the following sequence by 3 terms. So I'm giving you 2 minutes again, guys, to extend this sequence by at least 2 terms, and then from there, I'm going to be showing you how to work out the general term for this sequence. Okay, 2 minutes. Well done, guys. Let's now look at the pattern itself, okay? So you've got 3, 8, 15, 24. If you extend this sequence, you can't just go and say, okay, it's 24, then maybe the next one is 26, and then 31 and whatnot. You need to be logical about what you are doing. All right, so now we look at the first difference. This is 5, because you've got your 8 minus 3. And then 15 minus 8, that's 7. And then 24 minus 15, that's a 9. All right, So now, if you check carefully, this first difference is not the same, but there's something interesting about this. The second difference is 2. So it means that this is going to be the same throughout. So you've got a 2, 2, 2, 2. So up there was 11, and then you add it to that, then you get 35, right? And then that's a 2, so it means this one was 13, and then up there it's 48, right? And then it's 2, so it means here you had a 15, and then there it's 63, something like that. Guys, you'll work with your calculators. You are the new generation. Okay, now, so we move on. Okay, we have extended the following sequence by at least 3 terms. But the next question will be, okay, now, work out a formula. So you need to determine the general term. If I were to ask you, okay, term number 60, what's going to be term number 60 in this sequence? You'll be wasting time doing all these terms up to 60. When you're writing an exam, you will not finish the exam. Straightforward. Okay, so now let's just get to business. We know that it's Tn equals to an squared plus bn plus c. So the general term at the end of the day, we're going to have an squared plus bn plus c. All right? Now, we have agreed, so I am working with you guys here, that this term, that's your 2a, right? From the previous slide, okay? Then this one is your 3a plus b, all right? And then that is your a plus b plus c from that general term. So now if you look here, guys, it is straightforward. You can be able to find your a. So 2a is equals to 2, then our a is 1, okay? That can serve as our equation number 1. Now, once you've got your a equals to 1, you can take this 1 now and work with that, which is your 3a plus b equals 2, and it compares to what? To a 5. But you already have a 1, so you've got your 3 bracket 1 plus b equals to 5. So therefore, b is 2. All right. Now remember, guys, what's our main aim is to get the value of a, the value of b, and then the value of c. So at least we are moving forward. There is a, there is b, we're short of c. Now if you go back and check this one now, which compares to your first term, which is a 3, so you've got your a plus b plus c equals to 3. Now this was your 2, so that's now 3. Your a is 1, plus your b is 2, plus your c is 3. So it means that we've got c equals to 0, right? So in other words, you have your Tn equals to an squared plus bn plus c. Tn is, we worked out what a is, that was 1, so that's 1n squared, and then our b is 2, and then your c is 0. All right, guys, when you get to this point, you need to make sure that you test your formula, all right? So your general term, at the end of the day, before you hand in, all right? So you have your general term, which is your Tn equals to n squared plus 2n. Let's test T1 is 1 squared plus 2 bracket 1, which gives us a 3, okay? Let's see, that's a 3. We need to get 3, 8, 15, 24 at least. So 3, 8, 15, 24. Just to maybe prove if we are right or wrong, okay? Now, let's see, term number 2 will be 2 squared plus 2 bracket 2. That's equals to 4 plus 4, and that's 8. Now, guys, watch. We were correct on the first one, correct on the second one. Okay, now let's try term number 3. That is 3 squared plus 2 bracket 3, which gives us a 6 plus a 9, that's 15. Wow, we're still fine. And then term number 4, that's your 4 squared plus 2 bracket 4, which is, that's 8 plus 16, that's 24, and then it works out. So before you hand in your work, guys, please make sure that you check if your formula works for all your terms, because you can easily, when you are substituting on your formula, you can easily check that maybe I've done something wrong, and you quickly go back and rectify your mistake. Okay, so now we're going to take a short break, and then we come back and we continue with our quadratic sequences. Welcome back, guys. We are still continuing with our exciting mathematics here, your quadratic patterns. And I just want to remind you that, guys, it's not always the case that they will be giving you, when there is exam time, it's straightforward and so forth. Guys, sometimes they can mix sequences, and you have to be very observant. Okay, now the question that we're about to do, it talks about Tato and Tandi. So Tato and Tandi were doing a maths assignment, and we're asked to examine the sequence 3, 6, 12. Tato says that the next two terms are 24, 48. And Tandi disagrees and says that the next two terms are 21 and 33. So now if we just look at this, this is Tandi. Tandi is 3, 6, 12, 24, and 48. And then we have, who's this other one? Tato, 3, 6, 12, 21, 33. Now, explain why they could both be correct. So, I've given you these sequences coming from the Tandi and Tato. We're saying they might be both correct, but explain why they could be both correct. I'm giving you 2 minutes again, guys, to just work on this and tell how come these are different, but they can be both correct. Let's take 2 minutes, and then we'll work it together. Okay, you can now stop. Your 2 minutes is over. Let's just see how can they be both correct. Now, if you take case number 1, Thandi is 1. She's got a 3, 6, 12, 24, 48. Okay? So, Thandi has 3, 6, 12, 24, 48. Now, she is thinking, sorry, I am multiplying this by 2 to get a 6. I multiply 6 by 2 to get a 12. A 2 by 12 to get a 24, and a 2 by 24 to get a 48. So Thandi is looking at a sequence which we call a geometric sequence or a geometric progression. So she is not breaking any math rule. She is correct. Now we look at Tato's. Tato has a 3, 6, 12, 21, 33. Right? Now, Tato says 6 minus 3, it's 3. The 12 minus 6 is 6. And the 21 minus 12 is 9. All right? And then the 33 minus 21, it's a 12. Right? So she looks at this and says, this is 3, 6, 9, 12. So it means that the next one would be 15 and blah, 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 blah. But then this is 6 minus 3, 9 minus 6, which is 3. Then 12 minus 9 is 3. And then this is the second constant difference, which is a quadratic pattern. So it means that these two guys, they can both be correct, because this pattern, Tato's one, when she extends it, it becomes a quadratic pattern. So it's in the form of Tn equals to an squared plus bn plus c. But then who's the other girl? Thandi's one is a geometric progression, Tn equals to a Rn minus 1. Okay, right? We're still on the same question. We've done the first problem together. Find Tn, the general term in both cases. Okay, right. In case number 1, which is Thandi's 3, 6, 12, 24, right? So Thandi has got a common ratio of 2. So now her general term will be Tn equals to a Rn minus 1. Now remember that your a is the first term and your r is your common ratio. So she's got Tn equals to a is 3, bracket r is 2, n minus 1. So that's the general term for Thandi's sequence. Because if you're now going back, like we said, test if it's correct. If you put a 1 here, you've got a 1 minus 1, which is 0. That's 2 to 0, which is 1. 1 times 3, you still get a 3. Put a 2, 2 minus 1, it's 1. 2 to 1, it's 2. 2 times 3, you get a 6. If you put a 3, 3 minus 1, it's 2. 2 squared is 4. 4 times 3, that's 12. And on. This is 4. 4 minus 1 is 3. 2 cubed is 8. 8 times 3, that's 24. So you've got your, that's Thandi's pattern. Okay. Now, we look at Tato's one, which we ended up saying it's going to be a quadratic pattern. All right. So that's 3, 6, 12, 21, 33. So we've got 3, 6, 12, 21, and then 33. Okay. Now, looking at the differences, she's got a 3, a 6, a 9, a 12, 3, 3, and then 3. And guys, you know that this one is in the form of an squared plus bn plus c. But I just wanted to show you something else as well that you can quickly get to your general term. All right, so this, I'll call it a T1, and then this is F, and then this is S. All right, so now I want to show you another method here. The T1, just going to write a note here. So T1 is first term of the original sequence, okay? And then F is first term of the first difference. And then S is the second difference. Okay, now this formula that I'm giving you, it's a quick formula to get to your general term, your Tn equals to an squared plus bn plus c, but it is not on your formula sheet when you're writing your exam at the back as your formula sheet there. It's not there. So the formula is your Tn is T1 plus n minus 1 F plus n minus 1 n minus 2 divided by 2 times S. Now, if you can remember this, and it's just straightforward, you'll be plugging in your values, okay? So your T1 is your first term of the original sequence, your F is the first term of the first difference, and then your S is the second difference, and you sub in this formula. So we go back, what's our T1? That's a 3. Okay? Oh, goodness. It's the same numbers. But if you had maybe 3, 2, and then 1, we're able to just substitute on this one. You'd get the same thing at the end of the day. So it's 3 plus 3 bracket n minus 1 plus 3 bracket n squared minus 3n plus 2 all over 2 times the second difference is 3. But this one is not a very good example because your term 1 is 3 anyway, your first term of the first difference is 3, and then your second difference is 3 as well. But we will get just one example that's going to work perfectly with different numbers. Okay, all right? So we'll just stick to the old version. Your 2a is 3, and then your 3a plus b is 3 as well, and then your a plus b plus c is 3 for that sequence for Tandis. Okay, and then from there you can quickly work out, okay, your 2a is 3, so then a is 3 divided by 2. Now once you get to a, you substitute here, so 3 bracket 3 over 2 plus b is 3, and then your b is 3 minus 9 over 2, which is, so b is minus 3 over 2, and then once you get the a, the b, and the c, so a is 3 over 2, your b is minus 3 over 2, plus your c is 3. 3 over 2 minus 3 over 2, then you get your c is 3 in that case. So it means that you have your Tn equals to a, which is 3 over 2n squared, plus b, that's minus 3 over 2n, plus c, which is a 3. And now, if you just look at this formula, you will have your Tn is 3 plus your 3n minus 3 plus. Now, if you work this out. That is, this one is out. So you've got n squared minus 3n plus 2 all over 3. Now let's simplify this. It's a fraction. So you've got your 3 divided by 2 n squared, right, minus the 3 over 2 times that, you get minus 9 over 2n, right, and then plus the 2 times 3, which is 6 divided by 2, that's a 3. And then guys, if you simplify this is going to be your 3 over 2n squared, right, and then the like terms here, you've got a 3n, the minus 9 over 2n, which you get a 6 minus 9, and that's minus 3. So you're going to have a minus 3 over 2n, and then the 3 minus 3 is 0 plus that 3. So your Tn is 3 over 2n squared minus 3 over 2n plus a 3. Okay, so you get one and the same thing using different methods. Okay, now calculate whether 1005 could possibly be a term in Tato's sequence. Now, let's just check Tato's sequence. Tato had 3, 6, 12, and then 24 and 48, okay? She's got 3, 6, 12, 24, and then 48. All right? Now, if you were to check here, your formula for Tatos is Tn equals to A. It's Tn equals to A times R to n minus 1. All right? And then if you look, this is 3, 6, 12, 24, 48, and then you keep on getting even numbers. The next term is going to be even. The next one is going to be even, except that 3. So it means that the 1005 straight away is not part of that sequence. All right. Now, if we look on the next problem, which term in Tandy's sequence is equals to 111? All right. Just going to start you, and then, guys, you will finish this wherever you are watching. We know that Tandy's is Tn equals to 3 over 2n squared minus 3 over 2n plus a 3, right? So now we want to know which term it's equals to 111. So you given the Tn, which is 111, equals to 3 over 2 n squared minus 3 over 2 n plus 3. Okay, so you have to be working hard to get what n is, guys. Now, this will be your homework. We'll check it sometime, but thank you very much for listening and watching, and good luck with your mathematics. We need to set distinctions and the 90 pluses and so forth. And from my side, bye-bye.